All right. So we started off with a few answers before we even left class. Let's go ahead and finish off those answers. As a quick reminder, when we're naming acids, they always have an H in the formula. And when we're naming them, either they're gonna start with a hydro, because it's just an H in one element, or it's gonna be the name of the polyatomic and then acid afterwards. Now, when we name the polyatomic, we have to remember, oh snap, I need to go and change the ite and ate, okay? The ite and the ate is where the confusion comes in for some of us. There's a saying that we have in our notes, and maybe that's helpful for some of us as well, to write that in, so that way, you know, oh, okay, I can remember who goes to what, right? You don't have to memorize the polyatomics, not at all. They're on the formula chart. If you haven't had a chance to print it out, it's on our website, on our Blackboard. But when we're coming over here, it's either gonna be just a hydrogen plus an element. In that case, it starts with a hydro, the root word of the element, and ic at the end with the word acid. Over here, we have a hydrogen plus a polyatomic. We name the polyatomic. We change the ending if it's an ATE to an ic, if it's an ITE to an us, O-U-S. And then we still include the word acid. Now, ic, I ate a poisonous bite. Again, that's just a really common saying that we have, that many of us use to remember what changes to what. Let's see. So let's go ahead. I see that I have a hydro. So hydro means that it's just gonna be a hydrogen plus an element. And so all of them always start with an H and hydrogen. Bromic is bromine, B-R. Okay, capital B, lowercase r. The next one is a hydrogen plus a polyatomic. How do I know? Because it does not start with hydro. I know though that the formula is gonna start with a hydrogen, so H. But did you get, let's go to the polyatomic charts because I wanna make sure, because I know some of us may not have got this one correct. I'm gonna come over here and write it over here, H, and let's go to sulfurous, O-U-S. And on my polyatomic chart, that looks like this, O-U-S should have been an I-T-E. So, sulfite. Sulfurous, sulfite, I-T-E. Here it is, right here. And that's an SO3 with a -2 charge. So I'm gonna put over here SO3. This one has a -2 charge. My hydrogen always has a +1 charge. Did we remember, and I know I'm taking a little time up here, but did we remember to crisscross? Okay, that's what I want to make sure. So H2SO3, no parentheses needed. Okay, the next one, it's going to be a hydrogen plus a polyatomic. I know that it always starts with an H. It's ClO2. Okay, the next one, hydro, so that means that it's going to be a hydrogen only in one element. Chloric, which is chlorine, Cl. The next one, it doesn't start with hydrogen, so it's a hydrogen plus a polyatomic. My polyatomic here is going to be PO4, 3PO4. That 3 came from the crisscross coming down. Why are we still crisscrossing with acids, or do we have to crisscross with acids? We still do, because they are considered part of the ionic bond, not covalent bonding. Okay, next one does not start with a hydro, so it must be a hydrogen plus a polyatomic. I come over here, I take away that O-U-S, and it has to end up with an I-T-E, nitric. So let's come over here, that's gonna be NO2. The next one starts with a hydro, so that means hydrogen again, and only one element behind it, fluoric, fluorine. Down here below, we're gonna need to be naming them. So here is my formula. I have they all start with hydrogen, and they're all gonna end up with an acid as a name behind it, or the second name. I can see that this is a hydrogen plus a polyatomic, a hydrogen plus a polyatomic, a hydrogen plus an element. So again, those are gonna be hydro. Up here, I gotta go to the polyatomic chart. I'm gonna name the polyatomic. I'm gonna change ATE to IC, and I'm going to change ITE to OUS. Okay, just as a quick little reminder right here, I would make sure that I write that down on test day. So H2SO4 is gonna be sulfuric acid. Next one is a polyatomic, so I'm gonna name the polyatomic as is, nitrous, OUS, acid. Okay? Having that polyatomic chart is gonna be very helpful in front of you too. The next one is a hydro. And I see that there's an iodine there. I'm gonna use the root word of it, IOD, and then the last ic, acid. The next one is definitely a polyatomic there. So I gotta go to the polyatomic chart to find the C2H3O acetate, and we're gonna name it ACETIC. We change the ending to an IC from an ATE, and then we're gonna name acid behind it. The next one is an element right behind the hydrogen, so it has to start off with a hydro, is how it's gonna start off with. And I can see that it's a fluorine, so fluoric, FLUOR, acid. The next one has a polyatomic behind the H, or behind that hydrogen. So I'm gonna name the polyatomic as is. I'm going to change though the ending of the ITE to the OUS. So PHOS, PHOROUS from ITE, acid. The next one is also going to be a polyatomic, okay? In this case, we're gonna have I know that's cyanide, CN, where am I at? Was that on my polyatomic chart? Yeah, it is cyanide, IDE. What do we do on that case? Ended up with the ITE. And we have ITE, and we have ATE. Let me come back over here real quick, because I know that's cyanide, CN. IDE, okay? Look, here's another one over here, OH, hydroxide, IDE, okay? There's not a lot of those. ATE, ATE, ITE, ITE, ATE, peroxide, IDE, ATE. So there's not only but a few of them that are like that. I don't know in this case if you looked it up or Googled it, and if you did, I completely understand. Hydrogen, cyanide. So I apologize for that one being up there. I did not mean to. So absolutely, it would not be on a quiz or a test for us, never tested. And if it was quizzed, you let me know, because we're about to look at the quiz, and if so, I'll give back those points. But I apologize. So IDE, cyanide, would not be on there. The only ones that I'm concerned on for us right now is the ATE and ITEs. Okay, there's not a lot of them, but still, I apologize for that being on there. The next one, I see it's a hydrogen plus a polyatomic. Now, in this case, it's not gonna start off with a hydro. It's going to be the polyatomic only, fluoric, because I changed the ATE to an IC, acid. The next one's another polyatomic, so I'm gonna start off with the polyatomic name, carbonic. I changed that last part to the IC, acid. The next one is another polyatomic, so let's go to the polyatomics chart. Sulfurous, OUS from the ITE, acid. The next one's another polyatomic, so we named the polyatomic as is, we changed the ending of it, so it's going to be chlorous, acid. The next one, another polyatomic, nitric, IC from the ATE, so it got changed, acid. Then the last one is just the bromine next to the hydrogen, so we're going to call that hydrobromic acid. Okay, so I do apologize for that one. That wasn't even in our notes, and I didn't expect for us to do that one. Turn the page to the other side. The other side, I think, is more like mixed. Double check your answers. Don't forget, we gotta crisscross when we get to ionic bonding, and sometimes that becomes a little bit difficult for us to remember. The other thing is, when we're naming, and if it's going to be, for an example, Cr, like chromium, it's going to be a transition metal that's in the middle of the periodic table, we have to use those parentheses and put the Roman numeral, which is the charge number behind it, okay? So in this case, I'm gonna crisscross backwards. This 3 belong to the chromium, and the 2 belong to that polyatomic. So let's go ahead and name this one chromium, parentheses 1, 2, 3, because I get it from down here, close parentheses, carbonate, carbonate. The next one, arsenic, AS. In this case, it's not a transition metal, but I'm going to go ahead and name it di-arsenic. That's a 5. Then oxide. All right. So this is going to be a non-metal, and that one is also a non-metal. So we don't worry about crisscrossing there at all. The next one, nitrogen and oxygen, again, they're both non-metals, so we've got covalent bonding that's occurring here. We're not worried about crisscrossing, but we are worried about those little numbers because those are prefixes. The 2 is going to be a di-nitrogen. 4 is going to be a tetra. The O is ox. The ending is IDE. The next one, I have a potassium and a polyatomic. If I have a polyatomic and a non-metal, I still need to worry about crisscrossing because that's considered to be ionic bonding. But this is a metal and a polyatomic, still ionic bonding. I'm gonna name the first element as is, which is potassium. And then I'm gonna go ahead and go to nitrate. Nitrate. Lead, Pb. Lead is a transition metal in the middle of the periodic table. So in this case, I need to use parentheses. I'm gonna crisscross backwards. So I'm gonna say lead, L-E-A-D, parentheses 1, 2. I got that from this little 2 when I crisscrossed it backwards. And then I'm gonna go ahead and say oxide. P, phosphorus is a non-metal, Br is a non-metal, so in this case we have covalent bonding that's occurring. We're not worried about crisscrossing, but we are worried about prefixes. There is an invisible number 1 right here behind the P, but we do not name monos on the first name. So in this case it's going to be phosphorus. We are going to do the 5, penta, bromide. IDE. The next one, chromium. Chromium is a transition metal in the middle. So since it's a metal, it's ionic bonding. I'm going to worry about crisscrossing, back and crisscross. So in this case, the charge for chromium is actually a 3. And then I'm going to have chloride, IDE. The next one, I see a polyatomic. On this polyatomic, I'm going to name the first element as is, which is calcium. Then I'm going to name my polyatomic nitrite. K, which is going to be potassium, is a metal, and then fluorine is a non-metal. I'm going to go ahead and not use prefixes because that's ionic. I'm going to name the first element as is, which is potassium. Fluoride. Then the last one is carbon and then bromine, and they are both non-metals, so I need prefixes, but I do not use a prefix on the as a 1 for the first one. So I'm not gonna use mono, I'm just gonna say carbon, and I'm going to say tetra for the 4, brom for the middle of that word, the root word, I-D-E. Now we're gonna do the opposite. We have names, and we're gonna go ahead and come up with a formula, and that's what those are. Those are the formulas, right? So in this case, I need to think and remember and recall, if it's ionic bonding, I must crisscross. If it's not ionic bonding, then there's a prefix to go along with it. So just in case, I'm gonna go ahead and say ionic bonding, phosphorus is covalent bonding, di, covalent, tri, covalent. Do you see what I'm doing? Sodium is ionic, iron is a metal, ionic, lithium phosphate, lithium is metal, ionic, magnesium, why am I going blank for a second? Magnesium is gonna be a metal, ionic, tin is definitely a metal, that's gonna be a transition metal, ionic, di is a covalent, ammonium is a polyatomic, ionic, chromium is a transition metal, so ionic, aluminum is always considered metal, even though it's on the stair steps. So there we go. Hopefully that kind of helps us out a little bit. I'm just gonna go ahead and just do a little note over here. If it's ionic, I must crisscross. If it's covalent, use prefix. Okay, and that's just for myself, so that way, okay, here's what I need to do. Now lithium is gonna be in group 1, so it's gonna have a +1 charge. Phosphorus is a phosphide is a element on the periodic table. It's a non-metal in group 15, so it's going to be a -3 charge. Crisscross those. Lithium, Li3, P for phosphorus. The next one's covalent bonding, no crisscrossing. I need to look at prefixes. The prefix here is nothing. The prefix here is tri. So phosphorus, which is a P, don't put nothing behind it. Chloride, trichloride, which is chlorine, but tri means 3. The next one, I'm gonna have a di and I have a tri. So nitrogen, which is N, di is 2, oxide, which is oxygen, tri is 3. Okay, the next one, I have a tri and I have a hexa. So carbon is a C, tri is a 3. Okay, this is an oxygen for the OX. Hexa, which is going to be the number 6. Sodium. Now I'm going to go ahead and go back to my crisscrossing in group 1, +1. Sulfide, okay, sulfide, which is a sulfur, which is a -2. Crisscross those. Did we remember to put in 2S? Iron is a +3 charge. How do I know? Because the Roman numerals, okay? Chloride, okay, which is gonna be our chlorine. So in this case, this is gonna be a -1 charge. It's a non-metal in group 17. Let's crisscross those. Iron, which is Fe, the 1 comes over, so don't put nothing. Chlorine, which is a Cl, and then we must put the 3. Give it to me, Vanessa. Tell me.
For 15, it's Na, right?
Yes, it is. Good call. Yes, they are. I agree. Lithium is a metal in group 1, so it has a +1 charge, but do we all remember that all metals have a positive charge and non-metals have a negative charge? Just tossing it out there. Phosphate, because I don't see the IDE, that indicates that that is just a single element, right? Because a single element, we change the ending to an IDE. But when I see an ATE, that's a clue, oh snap, that's gonna be a polyatomic, okay? So my polyatomic, when I went to the polyatomic chart, is going to be a -3 charge. I need to crisscross those. So lithium, which is gonna now have a 3 behind it, the 1 comes over, so we do not use parentheses around it, PO4. The next one, magnesium, which has a +2 charge. Duh, it has a 2 behind it, I was thinking for a second. Iodide IDE shows me that that's gonna be an iodine, and iodine is a non-metal, it's over here in group 17, so a -1. Let's crisscross those, so magnesium, manganese, say magnesium, I2. 10, that has a +4 charge. Sulfide is sulfur, which is a -2 charge from group 16. Crisscross those, but did we remember that on here, we also reduce. That was one that needed to be reduced, a 4 and a 2. So when I crisscross those over, instead of it being a 4 and a 2, it's going to be SN, S for the sulfur, and a 2. Because the 2 comes over here, the 4 comes over here, and I have to reduce those to a 1 and a 2. The next one, I see that that's going to be a covalent bond because there's a 2. So arsenic, AS2. Penta, hydrogen's gonna have a 5. Ammonium, which is a polyatomic, and that's a +1 charge. Fluoride, which is chlorine, and that's a -1, a non-metal in group 17. Crisscross them over. So in this case, I'm gonna have NH4, no parentheses, because the 1 came over, Cl, and then that's it. Chromium has a Roman numeral 2, so that's a +2 charge. Sulfate, ATE, that indicates that that's a polyatomic, because it does not end in IDE. So that's gonna have a -2 charge. Reduce, and so in that case, it's going to be CrSO4, okay? The 2 and 2 reduced to a 1 and a 1. Hopefully we all agree on that one. And then the last one, ammonium, which is also, aluminum, which is a metal, +3 charge. Nitrate, ATE is an indication of a polyatomic, that's a -1. Crisscross them, they cannot be reduced. So Al, a 3 is coming over to the polyatomic, I must use parentheses, NO3, close parentheses 3. Okay, so there goes the answers to the homework. Hopefully not too bad. I think the crisscrossing for ionic bonding we may forget, and then we also have to reduce. That's always one of the, forgot to reduce kind of things. I'm gonna move the homeworks out of the way. The homeworks are due the day of the test, the notes are due the day of the test. Your, video notes are due the day of the test. So on the day of the test, we're gonna have a lot of grades to turn in. Now, before we go any further, I wanna go ahead and do this. I like this little thing, because, I mean, that's a lot of notes. I understand it's 2 units combined, but darn it, that's a lot of notes still. Now, we have covalent bonding and ionic bonding. Covalent is non-metal, where they share electrons. How do they share, or when we do a drawing, a line indicates sharing, just tossing that out there. Ionic bonding is metals and non-metals, but it can be polyatomic non-metal. It could be a metal and a polyatomic. It could be a polyatomic and a polyatomic. There's so many different things. But when we do the ionic bonding, which could be a polyatomic and a non-metal, which could be a polyatomic, whatever, we need to make sure that we have our charges so we can crisscross, right? Toss that out there. Now, electrons are actually transferred, and there's a couple of ways that we indicate or show that. Number one, we can draw arrows from here to here, showing that I gave it up and you accepted. Or at times you would see brackets around. They may or may not have the valence electron dots, may not, but they're gonna have a plus and a -1, just kind of showing, okay, +1, -1. Here's how I gave up, I accepted, I donated. Okay, those are acceptable, but this is not acceptable, which is the line, which indicates covalent bonding or sharing. Okay, so here's what we did last week. Then we talked about also our covalent bonding. Remember, we do not crisscross, we do not reduce, right? We show it by sharing with the line. It does not conduct electricity, hint, hint. That's a test question. It could be a solid, liquid, or gas at room temperature. It's a weaker bond compared to ionic bonding. They're a little stronger. They have very low melting points, means that they melt fairly quickly. And it says here that they have nonpolar equal sharing. Now, we know that not only can they be nonpolar, but they can be polar as well. Meaning that due to their electronegativity chart, they can be a little stronger and pull electrons a little closer to them, okay? Now, that's what we ended off at, and then we have our naming, we have our practice, we can do a few, we have our degree shaped polar, nonpolar, and then we have our acids over here. So all of this is kind of just a summary of everything that we've already done. So let's look at this part over here. Naming and bonding. So on naming and bonding, we've got pretty much, except for acids, pretty much you're either going to be, and what's on this side? Covalent, or you're going to be ionic. Except for acids. Now, if you're a covalent bonding that's occurring, then we have the first name, and we also have a second name. Now, on the first name, we use prefix. Except mono. Plus entire name. Like, we don't shortcut it, we don't root word it, it's just the entire name. Okay? So it's gonna be, and I guess I should have broken it up hard, I should have broken it like this. I should have done 1 and 2. That's what I should have did. We have prefix, we have the name as is. Now, again though, except for mono, if it's a 1, then we don't put nothing there, it's just one solid name. Now, the second name for ionic bonding, just as a quick reminder, it is the root word plus IDN, ends and IDE. Okay? So in this case, we're gonna have the root word, and then it's gonna end in IDE. Why aren't you stopping me? I messed up, didn't I? Root word. Let me look here. I have space. I don't know if you have space, but I need to put prefix plus root word plus it ends in an IDE. Forgive me. I just thought I would have a little space right there. I can squeeze it in. So 1, 2 parts of it, except unless there's mono. Prefix, always including monos. So we do prefix plus the root word, plus it ends in IDE. So 3 parts here, 2 parts here, unless it's gonna be mono. Alright? So this part right here is a prefix, no mono. This part right here is the full name. This part right here is a prefix, yes mono. This part right here is the root name. And then the last part is the ending. or the suffix. Now, how do I know which element's gonna be the first element? I don't know if we recall that. It is in our notes, but I'm just not too sure if we recall. Which element, who determines that he's the first element? The first element, we don't remember. It's going to be the farthest to the left or the farthest down. Okay, so if I got two of them and they're on, if that makes sense, if they're on the same group up and down, then the one that's further down is gonna be the first one. If they are on the same period, then the one that's further to the left is gonna be the one that's gonna be named first. That is something that some of us forget, and especially because it's kind of like already named for us, or the, what do you call it, or the formula is already given to us, and so it's like, oh, well then that's gonna be the first one. It's, most of the time it's given to you. But what if for some reason on the test, they give you a picture of two elements, two chemicals, and they're gonna be mixed together, and they're gonna chemically react and bond. Then how do you name it? Does that make sense? If they don't give you the actual formula or the name, because man, you already told me who came first. You gave me the formula or you gave me the name. But what if they just show you a picture of two bottles and they have this element in that one and this element in that one? Now you need to decide which name goes first, okay? And that's how we make the decision, who's further to the left or who's more down, okay? So that is a little tricky sometimes. The next one that we need to know is that the other thing here is that the subscript, and we know what the word subscript is, right? That's that little number behind it, equals the prefix, right? That little bitty 2 or the little bitty 3. Remember, there's no little bitty 1 because it's there, it's just invisible. And so, let's go ahead and continue with this part here. We know that a 1 is a mono, 2 is a di, 3 is a tri. I'm just going through them quickly, sorry. 4 is a tetra. If you need to take a picture of this, you're more than welcome to, or even after class if you want to take a picture of it. 5 is a penta. 6 is a hexa. That was a quiz, those were quiz questions. We will go over those in a moment. Hepta. 8 is a octa. 9 is a nona. And then 10 is a deca. Okay, and so those are our prefixes, but where do we get the